All right, welcome to Angular Lunch, hosted by Oasis Digital. We also put on Angular Bootcamp. We've been doing this a few years now, so I appreciate everybody coming out here. Our speaker today, Josh Godi, he's going to talk about Angular and web components. So go ahead, see you.
How's it going, everyone? Good? Ready to learn some Angular elements, hopefully? So what I'm going to talk about today is Angular and like how Angular breeds a lot of support for web components. I'm going to talk a little bit about web components but I'm going to stay more heavily on like how Angular builds all these cool tools so that we can build awesome web components and use them across a whole bunch of platforms. So to start it off, Angular and web components have a really great friendship. Angular, I want to say, has like the best support for generating web components out there. You can do basically your general Angular components and stuff, but then compile them as web components so you can use them across the board anywhere you want. So first off, who am I and why am I speaking to you guys? My name is Joshua Godi. I'm a software architect at Bullhorn. I'm an instructor here at Angular Bootcamp, a cat aficionado at home, and then there's a whole bunch of my contact information if you ever want to get a hold of me. Usually email's the best, and then I always post a lot of like cat-related demos and example projects on GitHub, so feel free to check those out. So first off, what are web components and how are they used in the Angular element land, right? So web components are basically the APIs that help you create these awesome reusable encapsulated elements, but they're not just the component layer. Web components in general are like the shadow DOM, HTML templates, HTML imports, and custom elements. So Angular Elements only uses one part of that in the whole library, right? So we only really want to focus on the custom elements part here. So what the custom elements are, they're, like I said, those reusable encapsulated custom HTML tags. Just like you are creating your Angular application, you create your component and you use it in your templates. They're the exact same thing. You'll see how we use that same paradigm to create these web components that we can use like in React projects and Vue projects or just in vanilla JavaScript. So like I said, they can be used in any framework or library that uses HTML. We'll see a couple of examples all across the board. They register with web components using the custom element registry. So we'll see some examples on how we actually register our web components and say what tag we're actually going to use for those web components. And then they also have their own lifecycle hooks, just like Angular components have like the ng on init and ng on changes. These custom elements will have the same thing. So like when the components initialize, when changes occur, things of that nature, and Angular taps into those specific life hooks and mimics them onto the Angular component lifecycle hooks. That's why we're able to kind of use them sort of together. So introducing Angular Elements. Before I go any further here, Angular Elements is still I forget what they actually call it, but it's like in their sandbox. So it's not like 100% stable yet. They're still playing around with it. I think as of Angular 6, like all the APIs are pretty well defined, but we'll probably see some changes coming with Angular 7 and the Ivy compiler to make like everything a little bit more streamlined when we're creating these components. But it's still at a state where we can kind of get in there, play with it, and get our hands dirty, and kind of just get used to the creating these elements. So with Angular Elements, we can create these custom elements basically by just using Angular components. We'll use the @component annotation, we'll specify a template, style URLs, do all of our same logic, and then the compiler will actually compile that down into web component. So that Angular component acts as like the host for our custom element. All of our logic's there. We can still do inputs. We can still do outputs. And then, so that acts as the host. And then the compiler will wire it up to the specific web components, lifecycle hooks, inputs and outputs, and so forth. So we can still do all the cool things that we can do in Angular land, like dependency injection, content projection. You can use multiple components, comprise them together, directives, services, all of that inside of here. But when it bundles up, whoever consumes that web component doesn't have to know about Angular or your service or any of your backend infrastructure. So why should we care about Angular elements? I ask myself this quite a bit. We actually have a component library that we have in-house that a lot of our external partners use, but that ties our external partners into using Angular. A lot of our partners have said, like, we're more comfortable with React or Vue, so something like Angular Elements can help us create a cross-platform, cross-framework library that our partners can utilize a lot more than just our Angular component library. So here are a couple use cases that make Angular Elements pretty cool. Is the door locked? No. Oh, okay. So a couple of the use cases that I can think of when I move towards using Angular Elements is especially when you're upgrading from AngularJS. So instead of using the ng upgrade module, we can create our Angular components, compile them as web components, and then use them in our AngularJS application. That way we don't have to worry about the upgrade module having AngularJS and Angular side by side. We can just utilize web components to kind of make it lightweight. When server-side rendering, when you're talking about like micro front ends, when you have like no framework and you're just doing very basic stuff, cross-platform compatibility and cross-framework compatibility, that's the one we're going to really focus on here. And then basically when you're creating a design system that you want to use everywhere. So these are really great for if you have like a UX team or a design team. They can create these elements, make them sort of standalone, and then your developers can kind of consume them in your applications. But we're going to focus more on the cross-framework and cross-platform compatibility. So it's really easy to get started with Angular Elements. The CLI gives us a lot of really great tools to make getting started as easy as possible. So there's just a couple easy steps to do to get started. So first, we're going to leverage the CLI. So we're going to make sure the Angular CLI is installed globally, and we want to make sure we have like a 6.0 version greater. So this isn't going to work on like the CLI version 5 or any earlier versions. So we're going to install that globally, and then we're going to use the CLI to just generate a new application like we would do at any point in time. So we say ng new. We're going to cd into that workshop, and then we're going to use the ng add. So the ng add is a custom schematic that the CLI will support. So we say ng add at Angular/elements. So the Angular Elements library has a schematic for what gets invoked when we want to try to add this package to our library. We say what project we want to add the Angular Elements to, and then that will automatically change our angular.json file, install dependencies, do all of the wiring up that we used to have to do by hand, now gets handled automatically for us with one command, which is pretty cool. And then what we're going to do is we're just going to go through our normal creation of components. So you're going to create a component for a button, a header, a user list, whatever you want to create these components for. You're going to just do them the standard Angular way. There's nothing really special to think about when you're creating these components. And then when it comes to actually compiling them as web components, that's when we just have to give a little bit of extra thought to it. So like I said earlier, you can still use the same dependency injection, services, view encapsulation, all of those things. Nothing really changes on the component creation layer. So then when it actually comes to telling our Angular application that we're actually going to be compiling web components, is we sort of hijack some logic in our ng module. So before, you have an ng module where you would bootstrap your application and it would actually render the page. But here we're really basically creating a library of components that we're going to use. So we don't really need to bootstrap, so we get rid of that. We still have the entry components block here, where we're saying all of the components that we're going to basically be compiling as web components. Here we just have a kitty cat button component that we're going to be making today. You see that here on line 3, we're importing this create custom element from @Angular/elements. So they give us a really nice, easy way to create these elements based on an Angular component. we're going to inject this injector into our constructor, and then we're going to hook into the ng-do bootstrap lifecycle. So when an Angular module gets created, just much like an ng on init or an ng on changes, this lifecycle will get fired when this module is actually bootstrapped. So here we're going to store a reference to the element. We're going to use that create custom element method that we imported. We're going to pass it our component. And then we're also going to pass it the injector so that that component can do dependency injection inside of it. And then finally, we're going to use the custom elements, which is supported on most evergreen browsers right now. I feel like you'll have a lot of issues, like if you have Internet Explorer support and things like that. But it's coming soon. You might need some polyfills for this custom elements. But then we're going to define an element, so kitty cat button. So here, this is where the selector is important. So this is what you're actually going to use when you are trying to consume this web component. And then we just pass it that element. So that create custom element really did all of the heavy lifting for us. It compiled, well, it basically translated our Angular component down into web component logic. And then we want to build it. So since we said ng add at Angular /elements, that changed our angular.json file to actually build our Angular elements for us. So we just do the ng build -- prod. And we do the prod, so it does some minification and some additional optimizations for us. And then one thing that's a little bit tricky is actually bundling this, right? So like when we build our application, it's actually going to create 3 or 4 files that represent our web component. But that's sort of messy to import into like a React application or a Vue application. So we want to kind of concatenate all of that down just to one file that we have to include. So here, this is just a node build script where we're just basically concatenating all of those files, the runtime, the polyfills, and the main file down to one file. And then that way we can just inject that one file into our HTML file, and then we can actually use our element. So the final step is where we can actually use it. So here is just a quick snippet of just an index.html page, no framework whatsoever. We're using the kitty cat button, and you can actually pass properties into those elements just like you would do in Angular. So like we're not binding anymore, we're just passing the name into the kitty cat button, and it'll render the proper name. We need to make sure to add that kitty cat button script to our HTML tag that actually brings in our web component and registers it to the DOM so that it knows how to render it and treat that element. And then you can interact with that element just like it's any other native HTML element, right? So we can get the element by ID. We can add an event listener. So here we're trying to hook into the output that we have defined on this element, and then we can perform some action when that output is triggered. And then we can update the name, and that'll also get re-rendered. So let's take a look at this real quick. And we'll look at the demo first, and then we'll kind of dive through the code, and then we can kind of see it a little bit more in action. So here is just that same example here, but so here's our kitty cat button, and this is actually my cat when she was a kitten. And then you see the name here is updated. And if I were to refresh, right, so the name is initially new here, but we had that set timeout for after 4 seconds when it updated the name, and we got updated. And then when I click on it, you see, okay, we have an alert that says you clicked on the cat. So pretty cool. Let's take a look at some of the code that we have here. So yes, if I can find the control button. Is that right? Is that good? Or more? One more? All right, we're gonna then close this. So we see on the surface of everything, we just have a normal Angular CLI application that was generated for us. We have our ETW file, so we can write our automation. We have our source, which has our app, and we have our same main ts index.html, those sorts of things. We see that in our angular.json, we still have our normal kitty cat button here as our project, and it has our project type as an application. And then when it comes down to here in our scripts, so when we actually build and it's concatenating all these scripts together, we see that the schematic for that ng add at angular/elements actually added a line here to add the node modules document register element, build, and then the register element JS file. So that's going to pull it in, and that's going to be part of our runtime.js file that gets generated from our build. So normally we would have to do that by hand, but we use the schematic to kind of do that for us automatically. And then if we take a look at the module that we saw a little bit before, we're importing that custom element, create custom element from at angular/elements. We're importing our Angular component that represents that kitty cat button. We're making sure we declare it and we mark it as an entry component inside of our ng module. And then we're hijacking on top of the ng do bootstrap lifecycle hook. And then we're going to create that custom element, pass the reference to that component, give it the injector so that it can do dependency injection. And then finally, we're going to define that component. So this is going to use that document register elements to actually register it as a web component. And if we look at our component, we see we have a pretty straightforward Angular component here, where we have the selector is the kitty cat button. But like, remember what I said before, this selector really doesn't matter, doesn't do anything. The selector that really matters is we're here where we define the kitty cat button. So in this case, they're the same, but here I can define the selector to be whatever, and then that's the selector you would use to consume and use your element. And then here we're using the same inputs. So I have two inputs on this component, one for name, and I'm defaulting it to Ginger, and then another input for the URL, and I'm defaulting it to the URL of my cat, well, the image of my cat. And then we have the output for the action, and then we're just going to create that as a new event emitter. And if we look at the HTML, that's the CSS. So the HTML is just a button, and we're listening to the click event. We're listening to it because the parentheses around the click action, and then we're just going to emit on that event emitter that we clicked it. So when we were looking at it, so I go back to 1, you see here when we're listening to that action that we have in single quotes there maps directly to our output that we have on our component. So we're firing an event called action, and then we're listening to that event just like you would listen to click or anything like that. And then here we have a span. So here you see we're still using the Angular template syntax here for rendering the name there in the double curlies. We're binding to the source property on the image to render the proper image of my cat. And then you can also use different view encapsulations. So here we're doing native. So this web component will actually use the shadow DOM. You can still use the emulated and the none. Just be wary, if you do the emulated or the none, you will also have to make sure that you're publishing out the styles that go along with your web component. And they would have to pull in the JS file and the CSS file to use the component correctly. So here we're using the view encapsulation, the style URLs, template URL, all of those are still the same. Nothing really changed on our component the way we defined it. And then, like I said, we had the build process, right? So we have the build where we're actually running the ng build with the prod. And then we're just using a node script to package and concatenate all those together. So in our dist file, we have that main polyfills, runtime, and scripts. And then in our elements file, we actually just have one JavaScript file that gets created. So we're concatenating all of those files together just to make one file that represents our web component. And then when we use it, just in standard HTML, so we have our button here. We have just some boilerplate code at the top, and then we're using our kitty cat button. So here we're passing in the name for new, and then this can be really whatever we want. So we can say like Angular Bootcamp as a plug. And then when I refresh, you see the name automatically got bound into our component, and then we still have that set timeout. So you can still grab the element just like you would grab any other element on your page, and you can interact with it. So here we're adding an event listener for that action. You can click the cat. But remember that action emitted a string, right? So if you wanted that event here, we can just grab that in our function. And then so we can say alert, you click the cat, and then we'll say, like, I cannot type. We could just console log the action, so you would have access to what actually got emitted across that event emitter. And then I'll save this, and then just to keep me safe, we'll try to show this. So we open the console, I'll refresh, and I click on it, and then you see that custom event got bubbled, and we can get the target and the event and what the type was and stuff. But that was just in a basic HTML example, right? So like, what if you want to use this in a Vue application, for example? So if we take a look at the Vue example, so here we have a really basic Vue application. It's all using just the CDNs. We're not actually using the Vue CLI to generate a whole application, but the result is the same. So here we still have our cat, and then we have the name of the cat now is from Vue. We can still click on it, and it alerts it that we clicked it, and it came from Vue. So if we look at that code in the Vue HTML, so we have a normal HTML file. We're pulling in the dist version of Vue. And then here we have a div that represents our application. And we're using our same kitty cat button component that we registered. But now we're using Vue template syntax to bind to the property name. And then we're listening for the action event that gets emitted. And then we're going to pass in the name. And then we're going to call alert when we get something along that action. And then we still have our kitty cat button here that is we're pulling in from our element that we compiled. And then we're creating a new Vue application. We're saying what our target element is, what data is. So we're saying name is from Vue, and then our methods. So our method, we had alert, where we're just doing the window.alert hello from Vue. So you see that instead of just passing the element, the data as strings, we can use the Vue data binding to actually change that over time. Or if data came from the server, we can bind it in there just as easy as we do in Angular. But also, what if you liked React more? So we see same example. We have our kitty cat component. Nothing really changed from the view since we're using that shadow DOM. Even if we had styles that changed the buttons or anything like that, it's not going to penetrate down into our component. And then we see the hello from React, and I click it. And I didn't wire up the click event for the React one. But so in the React HTML, we see more of the same things. We just have to pull in a little bit more stuff for React. We're pulling in the development version of React, the React DOM, and Babel to basically transpile all of this on the fly. We have our div where we're actually going to render our React application. We're still pulling in our kitty cat button web component script. Now here, instead of text JavaScript, we're saying text Babel, so Babel will transpile this in the browser for us. We're creating a React component that represents our application. We're setting some initial state, so here's the name that we want to pass into our kitty cat button, and then we have the render function, which returns the HTML that we want to render, right? So here we have the kitty cat button, and we're just passing in the name, which is we're just pulling the name of our state of our React application. And then we just call the React DOM.render to render our component to that app div that we defined. So we see by just using Angular elements to create one element using the syntax and the knowledge that we already have all around Angular, we can pull that into Vue and React and vanilla JavaScript very easily and use the same component across a myriad of frameworks. And then if there were bug issues or anything like that, you can fix it in one place, compile it, publish it out, and then all of the consumers would be able to pull that in relatively easily, and then they would see all the changes. They wouldn't have to pull in and do another npm install or anything like that, and then make sure that it didn't affect their systems. We make the web components so that they're kind of standalone elements that you can reuse anywhere. All right, so we'll go back to here. And one thing to note with there, so like you can publish web components to npm, but there's also a web components registry that you can publish to. If you go to like webcomponents.com, or yeah, I think it's .com, and there's just a whole list of web components that you can pull in to your application right away. And we didn't look at how you can use this in Angular, but it's the same syntax, right? So here, instead of the v bind on the name, you would do name in the square brackets, and that would bind to the name property. Instead of action, you would just listen for the event action with the parentheses. So really quickly and easily, you can just pull this into your whatever framework you're using and kind of get the ball rolling. All right. Any questions or anything? Yeah.
This looks great and super easy for like a simpler component. Does it scale well? I mean, if you have like a more robust component, I guess.
Yeah, so we could inject like services in there and do like an HTTP call to get data. All of that would be encapsulated in the web component, so you can do things like that. And if you wanted to use components inside of components in like your Angular, you just have to make sure you do the register, create custom element in the ng Bootstrap, like every element that you're going to use.
Okay, thank you.
What happens when you've got 100 components? If you wanted to have a library of your, awesome Angular components and package each one of them up, do you pay a significant overhead for every one of them, or do you pay it once and you get it for all of them?
Basically, if you have a whole bunch of elements, you would each element would have its own ng module, so you'd build each element separately. So you'd probably have some CI/CD process as you check in, so it knows what elements you changed and it would build and publish those automatically for you. So there would be some initial setup cost to set up that CI/CD process, but once you had that set up, then it'd be just as easy as doing a push.
I mean, that's good to know, but what I'm really talking about is the runtime cost. So when you have a lot of these things in your application, are you essentially getting a big chunk of Angular for every one of them, or a big chunk of Angular once that is somehow shared across all of these packaged up Angular elements?
Good question. So if you wanted to use a whole suite of the elements, what you would probably do is you would have a build step, you would bundle them all together. So instead of just doing the kitty cat button and then dog button, I don't know, I'm just doing all animals, but a separate button for each one, you would package them all up, so then you would only have the polyfills once and the main wiring up logic one time in your application. And I'm sure if we were actually using Webpack there and you had Webpack pull in all of those, most of the common stuff would go into the common bundle anyway, so you'd probably only get it one time.
And I may be misunderstanding part of this, but I'm fairly certain with Angular 7 coming out, we're compiling to native web components. So that might kind of eliminate the Angular side of it when you're packaging up. I'm not sure.
Yeah, that's a good point. Like when Angular 7 comes out, they will be compiling down just to like the native custom elements. So you won't get any sort of. I think it eliminates that runtime and that polyfills file that gets generated. So you just have your native web component code. Any other questions?
Josh, you mentioned view encapsulation a couple of times,
Mhm.
and I was wondering if the fact that it's supported is great, but you mentioned it several times. Is there anything we need to watch out for around view encapsulation inside of the Angular element packaging, or anything else? Is there anything that you run into that you know is going to cause a problem?
I would just look out for, if you're doing the native, just like the support for Shadow DOM in the browser you're running on. And then since we're doing that style URLs, it's automatically bundling the styles along with the JavaScript. If you didn't use style URLs and for some reason you just had like a separate CSS file that you maintained, you would have to publish that in, and then your users would have to pull in the CSS file along with the JavaScript file. But yeah, the big thing is just looking at the browser support. But for the most part, if they support the custom elements and web components, chances are they also support Shadow DOM.
Similar question going the other way. You mentioned event bubbling, and Angular custom events don't bubble across the parent-child boundary. Once an event actually comes out of your Angular element, is there anything special about that event? Does it act like a normal DOM event, or is it subject to the same restrictions that a typical Angular custom event would be?
That's a good question. I never played around with that, so I'd have to play around with that to see. I would suspect that it would just be restricted to the same Angular restrictions for the event bubbling, but I've never came across that exact example. All right, any more questions? Yep.
Are there any considerations in regards to styling? Like if you have a data table component that you've published as a web component and it's got a certain style to it, how would you make it fit into the host application style-wise? Would you just use the different view encapsulation and make them import their own CSS, customize it, or is there something else?
So if you wanted to like override the style of a web component that was published, so it'd be basically like you, because if they were using Shadow DOM, there would be no real way to like penetrate and override the styles for that. What was that? Yeah, so you can create inputs to override the styles. What I've typically done was just not use the Shadow DOM. So I used like the emulated Shadow DOM, and then you could override the styles in your parent application that would feed down into the web component. Yeah. So like.
With the browsers, it sounds like this is required. I mean, if you're going to be using this, you're going to be in an evergreen browser, so you would also have CSS variants. So you could, if you were using emulated view encapsulation as usual, as per the default, then you could use CSS variables or CSS custom properties, I guess is what I'm supposed to call them now, and flow information down that way. So you wouldn't necessarily have to have a custom style sheet. You could simply say, oh, the background color looks like this, the background image looks like this, the spacing looks like this, all via CSS custom properties. And they would flow down just the same way that anything else would with emulated view encapsulation.
That'd be cool. And then like when you publish your web component out there, just in like your README, you could document all the variables that you use that people can override and like change the styles as needed and stuff. Yeah.
Have you done anything like as far as like a library goes?
So I have not yet. We're sort of in the process right now of taking our in-house Angular component library that we have and bumping it up to be on Angular 6. And then once we get there, we're going to be starting the process of having our Angular library that's still published and published on NPM, but also have a separate build process that generates web components for every single element. That way they can use different pieces. So haven't got full-fledged creating Angular elements like a full library of it, but hopefully we'll be getting there soon. All right, any other questions? Well, thanks everyone.